Welcome to this session. In this session, we discuss how to use Lagrange reduction method to reduce a quadratic form into canonical form, or to reduce a quadratic form into sum of squares. So the quadratic form given is 6x1 squared plus 3x2 squared plus 3x3 squared minus 4x1 x2 minus 2x2 x3 plus 4x3 x1. So this problem assumes that you know how to play with completing the squares method to reduce a quadratic expression into a sum of squares. So majorly that's what all the process of Lagrange reduction is, on reduction of a quadratic form into sum of squares. You simply use completing the squares method to express the terms as sum of squares. So solution. You see, these are just a sum of terms. So this can as well be written as, so we say the given quadratic form can be written as, so I'll write 6x1 squared, and then I bring minus 4x1 x2, and then I bring 4x3 x1, and then I write 3x2 squared, and then plus 3x3 squared, and then minus 2x2 x3. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I've rearranged this term so that I have terms with x1 starting, followed by the rest of the terms in x2 and x3. So that's step one. So step two, we apply completing the squares to have the quadratic form expressible in squares. Now, so you see the first three terms, these terms here, I can write 6 into x1 squared minus, I remember even before I put 6 outside the bracket, so let me just do step by step. I can have this one as 6x1 squared, 6x1 squared minus 4x1 into x2. And then when I factor out -4, then this plus, then I must have a negative sign here, so that when I open, I still get back my positive sign. And then plus 3x2 squared plus 3x3 squared minus 2x1 x3. I want to concentrate on these first two terms after factorization of minus 4x1. So I'll put out 6 and then write this one as x1 squared minus, now when I factor out 6, I need to write here 2 over 3 x1 into x2 minus x3 plus 3 x2 squared plus 3 x3 squared minus 2. That was x2, not x3. So this must be 2. 2, 3. Now remember, when I I multiply through by 6, I'll have 6 times minus 2 over 3, I get minus 4. So that's why I have this number, minus 2 over 3. So remember this now, we need to complete the squares here. Remember, if I have a quadratic expression, if you have a quadratic expression, x squared plus bx plus c, then to complete the square, you simply need this coefficient. Once already you have ensured that the coefficient of the variable squared is 1, then this coefficient of x per 1, you divide by 2, then square, add on the expression, and then subtract so that you don't change the meaning of the original expression. So here, our b is minus 2 over 3. So when you divide by 2, we'll have negative 1 over 3. And then, so remember, it is where, so like the variable here in this general x squared plus bx plus c, the variable here is x1. So therefore our b term is minus 2 over 3 x2 minus x3. So when I divide by 2, I'll get minus a third x2 minus x3. So this is what I need to say. I'll have 6 into x1 squared minus 2 over 3 x1 into x2 minus x3, and then plus, so my b over 2 is this term here, so minus a third x2 minus x1, x2 minus x3 squared and then because I have now added this term here, so then I close brackets, then plus 3x2 squared plus 3x3 squared minus 2x2 x3. But remember, I've added a foreign term to my expression, so I need to balance by subtracting. Six times this same term here. So I have 6 into x1 now minus a third into x2 minus x3 and then square. So plus by introduction of this term, so the square of this term is minus 2, so this will be 1 over 9 x2 minus x3 squared. And then there's a 6 here. So I need to multiply by 6 here. So then I have to subtract 6 over 9 into x2 minus x3 squared. You should check that when you open this, when you open the brackets here, you'll see that this term and this term here will be canceling out, and then you remain in the original expression. So that's why you have to remove this term, because it is a foreign term. It is now, if you don't subtract, then it will be changing the original expression. So plus 3x2 squared plus 3x3 squared minus 2x2 x3, and then minus 6 over 9 is the same as 2 over 3 into x2 minus x3 squared. So at least we have succeeded in getting the squares for x1, x2, and x3 in this part. So here we have 6 into x1 minus a third x2, minus is plus, a third x3, then square. Now let's open this. So we'll have plus 3x2 squared minus plus 3x3 squared minus 2x2 x3. So when you square this one, square this bracket, you'll have negative 2 over 3 into x2 squared minus 2x2 x3, and then plus x3 squared. So we'll have 6x1 minus a third x2 plus a third x3 squared plus 3x2 squared plus 3x3 squared minus 2x2 x3, now minus 2 over 3 x2 squared, minus is plus, 4 over 3 x squared x3, x2 x3, and then minus 2 over 3 x3 squared. So let's add like terms. So x1 minus a third x2 plus a third x3 squared plus now 3, and then this is minus 2 over 3 gives us 7 over 3 x2 squared, and then 3 minus 2 over 3 gives us 7 over 3 x3 squared, and then here we have minus 2, and then plus 4 over 3 will get us minus 2 over 3 x2 x3. So this we can write it as 6x1 minus a third x2 plus a third x3 squared. I can write this one as 7 over 3 x2 squared. I bring this one minus 2 over 3 x2 x3 plus 7 over 3 x3 squared. Now, at this point here, let me now get complete the square for x2. So this one I can write it as 6 x1 minus a third x2 plus a third x3 squared. Now I factor out 7/3. So I'll have x2 squared minus, now what should I multiply by 7/3 to get 2/3? So this would be 3/7, 3/7. So x equals to 6/21. So this one is 6/21 times 2/3. So this is 1, 2. No, so 2/3 times x equals to 7/3. So 3/2, 3/2. So this and this, this and this. So it should be 2/7. So 7/2 times 7. Okay, so now once we factor out 7/3, so 7/3 minus 2/7 x2 x3 plus 7/3 x3 squared. I see when I open bracket, I still get back my minus 2/3. So I now complete the squares. So remember here now, we are completing for x2. So therefore our b term is minus, our b is minus 2/7 x3. So when you divide by 2, we get minus x3/7 or minus 1/7 x3. So we'll have 6 x1 minus a third x2 plus a third x3 squared plus 7/3 into now x2 squared minus 2/7 x2 x3 and then I add the square of b/2, which is now plus 1 over or minus 7 minus 1/7 x3 squared. Then here we have 7/3 x3 squared. But because I've added a foreign term here, minus 1/7 x3 squared, so it's the same as 1/49 x3 squared. And then times this one here, I have to subtract 7 times 3, 7/3 times 1/49 x3 squared, so that I don't change the original the meaning of the original expression. So with that operation, this will give us 6 into x1 minus a third x2 plus a third x3 squared plus now 7/3 into x2 now minus 1 over 7 x3 squared, and then plus, now here we'll have 7 over 3 x3 squared minus 7 over 3 times 1 over 49. That's 1 over 21. X3 squared this plus negative sign. So then now 7 over 3 minus 1 over 21. That gives us 16 over 7. So plus 7 over 3 into x2 minus 1 over 7 x3 plus 16 over 7 x3 squared. I say every term in this new expression is a square. You see this is a square, this is a square here, this is a square here. So that's q of x1, x2, x3, which was given by 6x1 squared plus 3x2 squared plus 3x3 squared minus 4x1, x2 minus 2x2, x3 plus 4x3, x1 is equals to, so I have gotten the answer to be 6 into x1 minus a third x2 plus a third x3 squared plus 7 over 3 into x2 minus 1 over 7 x3 squared plus 16 over 7 x3 squared. So letting this to be y1, this bracket to be y1, this one to be y2, and then this one to be y3, to say x1 minus a third x2 plus a third x3 to be y1, and then x2 minus 1 over 7 x3 to be y2, and x3 to be y3, then the canonical form or the reduced quadratic form becomes, so Q now in terms of y1, y2, y3 will be 6 y1 squared plus 7 over 3 y2 squared, and then plus 16 over 7 y3 squared. And you see in this transformation, this implies that x3 is y3 And then, so which means x2 will be take this one to the right. So we'll have y2 plus 1/7 y3. And then x1 will be y1 plus a third into y2 plus 1/7 y3, and then minus a third y3. So replacing the value of x3 by y3. When you simplify, you get y1 plus a third y2, and then minus 2/7 y3. So this is the transformation between the x variables and the y variables. And so this is the sum of squares that the question wanted us to find. So the key thing here in this question is simply the concept of completing the squares. That's majorly what is being applied repeatedly to those variables x1, x2, x3 to get the desired solution. So if you have knowledge on completing the squares is well, you shouldn't have problems on that one. If you have problems, then please check the work on completing the squares so that things makes a lot of sense on your side. So this is canonical form. Thank you.